Students, today is the January 22nd review of M4 and M5 talking about energy, which we saw a lot of questions in class concerning it. So I'll walk through those questions. For this video, we'll be talking about the energy in the Atwood machine. So conservation of energy started with focusing on potential and kinetic energy. We eventually added spring energy on the following unit, but the apparatus, the setup is going to be the same for all of these. Okay, so we see our first question of the cart resting on the incline. It's connected to a weight and it's suspended vertically. Okay, and the weight drops 0.5 meters. It is not cut from the string, so the cart also moves 0.5 meters up the ramp. And the first question asks, what is the final speed of the system? So for that, we're going to look at this setup, drawn the same way. We see we have all the elements here. So the hardest part about this, from what I can tell, is knowing your zeros, okay? So cart 1 starts at the bottom, so that is 0. It starts not moving. This one starts up high, so it has a number, but it is not moving. Okay, so if things are not moving, no kinetic energy. If they're at their lowest point, no potential energy. Now, potential energy will go up as this increases. So this will have energy. This will be moving. This will be at its lowest point. So it will not have energy, but it will be moving. So now we have all of our zeros listed here. So now we can look at what's going to happen. Okay, so this first one is pretty straightforward. Okay, so this is for 2. Okay, over here is when some of these numbers might still have to be derived. Okay, first of all, these are tied together by a string. So V1 is going to equal V2 because the string is present. Okay. Other things to note, we know this height. Okay, we also are going to need to find that height right there. Okay, so in order to do that, a lot's happening on this triangle, so I'm just going to go ahead and draw another triangle on another piece of paper here. Okay, so it's the same triangle. I'm just going to draw this. Okay, so we have 0.5 meters. We have 15 degrees. Okay, so this is going to be 0.5 times the sine of 15 degrees. Okay, and I have that written down here. 0.129, 0.129 meters is this height. So that's what I'm going to put in here. Okay, so now let's keep going with our numbers here. So we have M2 and then we had M1 times H is what I just found. M1 is, so this is where I can call all of these V, okay, because this and this are all the same. Okay, now we can start working on our calculator here. This should be 0.735 joules equals. That's going to be 0.5 plus 0.075, so that should be 0.032. Okay, so that is our velocity in meters per second. Okay, so again, the tricky part is all right here, getting all those lined up, recognizing that this goes up, and then the algebra falls out from there. Okay, so if that is our part one, we're going to use that number now to solve the next one, because number two said find the acceleration. Okay, we can do this a number of different ways, but the fact is, if there's an equation where we know everything except the variable we're looking for, we should be able to solve it fairly easily. So we know the final velocity, and we know that both objects moved 0.5 meters. Okay, 2 times 1/2 is 1. Okay, square root, or the 0.56 squared is 0.0316. Okay, so as long as we have this, the hard part is finding this one. As long as we have that, the algebra becomes very simple. Okay, this next one is a little bit trickier, and there's two different ways to solve this. Okay, I'll actually walk through and solve both scenarios, because in class I just did one. So in class I just showed you, if we are looking at M2, okay, and we want to look at, here's tension and here's the force of gravity, okay, then we can say that the sum of our forces in the y equals mass times acceleration in the y. Okay, so we can take the tension plus the force of gravity equals mass times acceleration, which is going to be this number. This is going down and this is going down, but this is going up. So we're going to need to show that with our numbers here. So we'll have T, okay, times, we said 0.15, negative 9.8. Remember, now this is going down, so that's what I want to track here. It's pulling down, and then 0.15 times negative 0.316. Okay, so we multiply those out and we get T equals, or T minus 1.47 equals negative 0.0474. Okay, so that means T equals positive 1.423 newtons. Okay, so that's how we can solve it this way. What happens if we want to look at the cart, okay, and we want to look at this tension, and we have this gravity? Okay, we're still going to use acceleration, all right, but we're not going to use all these parts. I need to split up this force of gravity into an f of x, and let's go try to get that a little more y, f of y. Okay, so we have the force in the y and the force normal. We're not really concerned about that because this whole thing is moving in this direction. Okay, it's accelerating that way. So that's where we want to focus our forces when we do sum of the forces in the x equals mass times acceleration in the x. We're looking at this direction, which means, again, we're going to have to do, oops, try to keep it in, tension plus f of x is going to equal acceleration in the x. Okay, So I mean, you could plug that number in, but I'm trying to show we can get the same number doing this. So how do we find our f of x? Okay, well now we need to go back to our original drawing. That was 0.5 meters or kilograms. So we would have another little drawing here. Let's try to do it a little bit better here. Okay. All right, so this is going to be our mass times gravity, our 0.5 times 9.8. Okay, this is going to be that number, which is going to be 0.49 times the sine of theta, okay, which was 15 degrees. Okay, so we can take that and solve that as well. All right, and I was talking too fast here. This equals 4.9. So let me just rewrite. F of x is going to equal 4.9 newtons times the sine of 15 degrees, which is 1.268 newtons. So that's f of x. So that's going to be this number. So now we can come back here. Tension plus 1.268 newtons equals, which mass was this? This was 0.5 kilograms. It's still accelerating at the same rate, 0.316 meters per second squared. Now let's think about this. This is going up the ramp. This is going up the ramp. This is going down the ramp. Okay, so I'm going to call that one down and call these positive. Okay, and when we do that, we're going to get same number. Okay, so that's two different ways you can solve that problem.